Hello, everyone. Welcome to the AMT Tech Trends podcast, where we discuss the latest manufacturing technology research and news. Today's episode is sponsored by AM Radio. I am the Director of Technology, Benjamin Moses, and I'm here with
Stephen Lamarca, Technology Analyst.
Steve. How you doing today?
Doing great.
Yeah, you doing well?
I am doing well. I am upset. I'm on a maintenance kick lately.
Yeah.
MFG is coming up.
Right.
And I'm doing a small talk at MFG on maintenance.
Okay.
When people talk about Industry 4.0 or advanced manufacturing, almost always predictive maintenance comes up.
Okay.
And, just like when digital twin's still a hot topic, but a lot of people, it's one of those topics that everybody admittedly pretends to know about and really knows just enough about to keep up a conversation. But it's one of those things that needs to be explained more. And I feel like I've wrapped my head around it enough to explain all the different levels of maintenance.
Okay.
And I'm trying to come off as this SME in maintenance, and yet, admittedly, as much as I love maintenance, maintenance isn't just for manufacturing.
Right.
It's part of almost everybody's daily life, unless you're one of those people that lives in a big city and you don't have your own vehicle to commute to work. Loser. But you need to maintain a vehicle if you commute. Even if it's a bicycle, you still need to maintain it. There are things to do. But one thing a lot of people don't think about in maintaining, and certainly my fellow watch collectors, people who are getting into collecting watches, admittedly, even the ones who have been collecting watches, don't like talking about maintenance.
That's fair.
Because it's a Schedule 1 maintenance with watch collecting. Even the highest end, the most advanced technology watches are level 1 maintenance. That's binary. I like to call it binary maintenance.
Okay.
Meaning it's the farthest, almost the farthest. It is the farthest from predictive maintenance or prescriptive maintenance, which is advanced maintenance theory.
Right.
But it's reactive. It's if something's broke, fix it.
So when my battery dies and I would change the battery, that's level 1. Okay.
Yeah. It would be much more advanced. Like you would have level 3, like condition based or predictive. If you got a notification on your watch saying, "Hey, the battery is about to die."
Okay.
So I don't want to. I'm not going to say it. Never mind. Smartwatches are dumb too. But I've my Breitling has stopped working.
Oh no.
I have 2 watches. They're nice watches.
Sure.
But which is why I only have 2 of them. And one's on a leather strap. Well, not technically leather. It's horse butt. It's the subdermal membrane of a horse's butt, shell cordovan.
Thanks for that.
But organic straps I wear in the winter.
Okay.
And in the summer, when you get sweaty and disgusting, that's when I wear metal straps, a metal bracelet, a stainless steel bracelet. And my Breitling has the metal bracelet on it. And I have come to find, when I'm getting ready to take it out of its winder, that it is stuck on the 30th and the second hand is not moving. And I tried giving it a wind. It is fully wound.
Right.
And it will not start. I'll even give it like a gentle twist.
Sure.
That hairspring will go for like a few oscillations and then it stops. And it's like, all right, something is jammed in the drivetrain and this is going to be dollar signs.
Yeah.
Sorry,
man. Yeah, I was thinking about that too because I've for maintaining my cars, I actually do enjoy working on my cars.
Yeah.
Although the modern cars have annoyed me because the floor pan. I have to remove the entire floor pan to change the oil, which I would like an access door.
Yeah.
But whatever. So
or at least a little hatch.
A hatch, something. I don't need to remove half the car length of floor pan.
Oh man.
I had to remove 15 screws on the Porsche.
Yeah.
That's a headache. Underneath when you're on your creeper.
Riddle me this, because it is a Porsche, which is a semi-exotic car.
Sure. I got to use, guys. Let's take it easy.
But still, how have you changed the oil on it yourself?
I have. Yeah.
Okay. How many drain plugs are there?
Just one.
It's really. Are you sure it's just one?
It's an Audi engine.
Okay.
So it uses the Audi supercharged engine, and then it's electrified. So it's a hybrid. So there's not a Porsche engine in the model that I have.
Okay. Because I know, I remember it blew my mind the first time I read that, like the Ferrari V8s sometimes have as much as 12 drain plugs. That's wild. And now that's also a dry sump lubrication system. So it's the oil's not collecting in the oil pan under the car. It's in a sump.
Right.
And I have heard a lot of like going to car meets and car shows, like Cars and Coffee.
Yep.
I've run into a handful of Audi owners that have been like, yeah, I used to have an Audi with a dry sump lubrication system. They stopped making them for a good reason, because you tend to run those dry sumps dry every now and then it becomes a big problem.
So in my car, I changed the oil roughly on time, was what the computer said, but I don't have the tool to reset the ECU to tell I notify that, which is I need to look around. It's a headache, but I'll let it ride. But my wife's truck it's fairly easy to change her. They can drive it on the ramp, and I have to remove the floor pan also. But I'm like 3,000 miles behind on the oil change on that because the winter. I didn't change the oil before the winter hit, and it's been a fairly cold winter, and I don't feel like changing the oil during the wintertime.
Yeah. I know a few people with Mazdas. Like, we know a few people. Russ and Melissa both have Mazdas. My sister has a Mazda, and they get a little notification when it's time for service.
Yep.
And the service light comes on either when they reach a certain amount of miles or when it's been a certain amount of time.
Right.
Not uptime, but like uptime and downtime together, regardless of whether or not the car's been running. I mean, and that light will come on. What's so cool about Mazda, you can access that from the menu.
That's cool.
From like before you start the car, or even if the car's running. If you're stopped, you can just dig through all of like the menus and you can turn the light off yourself.
Is there something you actually like to maintain?
Okay, so
that you do yourself.
I'm about to be shamed with my car.
Yeah,
I do very little with it. I changed the air filters,
That's
the
cool.
cabin air filter and the engine air filter, because there's no reason why you shouldn't be doing that. The one thing I do like to maintain other than the air filters, I've cleaned the, not the EGR, mass airflow sensor.
Oh, sure.
That one's easy to do.
Yep.
You buy a aerosol can of mass airflow sensor cleaner, you unbolt, there's two bolts, and then you unplug something. You take it out, you hold it in front of you about like 6 inches in front of the can. You just spray the hell out of it,
and then smell all those fumes, and then put it back in.
And then you put it back in.
Okay, good.
Well, you want to let it dry for like 15 minutes first.
Yeah.
But I just put it back in. I don't start it right away. But like I'll do that during lunch in the garage while at work.
Right.
It's easy to do. It makes the car run a lot better. Like it's noticeable when you have a dirty mass airflow sensor, and then you clean it. It's night and day. You don't notice it as it's getting dirtier.
Sure.
But like when you clean it up, it helps the throttle response. It's wild. But other than that, I don't work on my car at all. I have so far with the new motorcycle, I've done all the maintenance myself. Now it is new, so I mean I haven't even done the break-in service. But I've added a lot of parts to it.
Right.
Like Kawasaki original equipment parts. The instructions are good enough,
right?
Even though they're really tiny. Sometimes you need like a loop, I think, to read those instructions. It's not like more than a magnifying glass. But I've done that. But like Jay Leno said once that he prefers standard or naked bikes to sport bikes.
Okay.
Sport bikes have aerodynamic fairings covering everything, and a naked bike or a standard bike like a Harley Davidson or a UJM, a Universal Japanese Motorcycle, are uncovered. So you can see everything. He likes those not only because they're easier to work on, but because it's like a mechanical watch that's either skeletonized or has a display back. You can just see all the engineering beauty that went into it. And I subscribe to that.
Nice.
But the beauty of a naked, unlike a watch, you can work on it yourself.
Yeah. Simple tools, you can get to everything. That's great.
Yeah.
I like working on firearms. That's the coolest thing I like. There's a couple of reasons why. One, I like the solitude. It's like complete silence usually when I work on it, usually in the garage or in the basement. I try and do in the garage because there are fumes involved. And then I actually recently been doing gun maintenance with a friend. So
oh, cool. Scott?
No.
Okay.
And then the other maintenance is once you get it clean and get it lubed, it actually feels really nice. Like you can work the action.
Right.
And it feels significantly different than when it was dirty, or like if you look down the barrel and you see like there's no debris, no copper fouling or anything. I mean, not going to see copper fouling, but it looks clean, right? When you shine the light down there, it feels really nice.
I have to be honest with you. As much as I am a huge fan of maintenance in theory, I hate it in practice. I love maintaining, because like, you brought up firearms, which
Right.
is another thing.
Yep.
I love cleaning my Benelli.
Yep.
But that's because all of the internals are chrome plated.
Right.
And chrome is especially polished chrome,
Yep.
high luster chrome is the easiest surface it just wipes dry. You don't even need any solvents.
Yep.
Everything just wipes clean.
Yep.
I haven't cleaned my AR yet. And I oil it because after
Yeah.
you put one round through it, it's dry. Like all of the oil is like gone.
I don't use oil. either.
It's also really funny when you have an empty firearm
Yep.
and you're just like hanging out in the living room or whatever. Firearm's clear, unloaded, and you just rack the action really fast.
Right.
Like you a handful of times you
Yeah.
rack it really fast, and you can actually smell the oil like burning off to the friction because
Sure,
it's such a
sure.
tight tolerant system.
Let's get we got to have an article we're going to talk about maintenance later on too, so we'll get into that.
And
later.
before we get into articles, we
Yep.
have an ad read. This podcast episode is sponsored by AM Radio. AM Radio is the new podcast from Additive Manufacturing Media. Join editors Pete Zielinski and Stephanie Hendrickson and Julia Heider as they share stories of companies succeeding with 3D printing today. Talk about emerging trends and discuss the future opportunities and potential for AM in the context of the larger manufacturing landscape. New episodes are published every other week. Subscribe now on Apple or wherever you listen to podcasts. Tune into Additive.
See, the first article I have is about new charging technologies and warehouse automation from machine design.
Oh.
Where-
Charging technologies.
Yeah, I mean, so some of our audience may not be using warehouse robots, but the big thing is if you have a warehouse, it's probably going to be automated to using AGVs or AMRs.
Oh, gotcha. Right.
And then we have an IMR use case later on we'll talk about too, but it talks about the value of automation and the challenges that they have on using this equipment in the floor. So, using an automated warehouse has 76% boost in inventory accuracy, and 99% increase in accuracy, as in picking the right object, and then 40% more likely to ship that same day. So in terms of the business need, right, the Amazon ship that day or
Yeah.
2-day shipping, you've got to get it in a box fairly quickly, right? So accelerating
Absolutely.
from order to picking to getting into a box, obviously there's value in doing that and benefits to the end user. But what they're talking about is these remote vehicles have massive batteries. Just like a EV car, if you need to charge it, you can't drive it anywhere.
yeah.
So the article gets into issues on with the current state of the landscape of we've got all these autonomous vehicles or autonomous robots on the factory floor, but how do we go to the next step in keeping them active, keeping them engaged all the time? So it's interesting where it looks at a couple of different ways where now you apply a little bit of intelligence system. So you look at opportunistic charging. So similar to like if you're actually driving across the world in a Tesla, right? You're not going to drive it till it's completely dead. You're probably going to drive it to like 50%, charge it so it charges faster,
yeah.
and then drive another 50% and then charge, or down to 25%, or wherever the next EV charging station could be.
I mean, and that strategy could change with the development of batteries.
Exactly.
Because remember, like before smartphones became like the norm,
Right.
when it was still like flip phones and like slides and T-Mobile sidekicks and Motorola Razors.
Yep.
The rule of thumb was you use the battery all the way down to 0,
Yep.
then you charge it all the way up to 100.
Right.
Now with smartphones, if you want to keep that battery alive because the processing power is so crazy high, if you want to keep the battery healthy for longer, you charge it when it hits 50, and then you charge it to 80.
Right.
And apparently that's the healthiest for the battery. So obviously not a lot of people do that because, it's...
Why would you?
Because there's life. There's a thing called life that gets in the way of charging batteries.
Exactly.
But if I would imagine if you were to, and if you could physically drive across the world
Right.
in a Tesla, assuming this battery technology is the same as modern cell phones, which I have no reason to believe it's not.
Right.
You would drive it until it's 50% power and then
Right.
charge it to 80 and
Right.
then continue again until you're back down to 50 if you
Yeah.
want to keep that battery
Yeah.
working.
The big takeaway is, there's a really strong connection between batteries, right? There's significant advancements in batteries. You talked about 3D printing batteries and the different minerals and chemicals used to extend the life and get charger, but also the charging capability. We're seeing higher voltages, higher amperages in EV vehicles to get that charge down fast. But I think one thing that isn't talked about enough is charging strategies. And it's going to play a lot in the automated robots of how often do you charge? Do you even charge it? If it's in the article later on, we talk about Ford, if it's at a station, why not just have the robot, the IMR, plug itself in while it's being operated? You know, there's a lot of different ways to solve this problem because it's at a machine that needs power. You know, just plug itself in for a hot second and then do its thing and then unplug itself. So
yeah,
some random thoughts. Oh,
I don't envy people who are in battery development.
Why not?
Because so I have been told. I was told at a very young age. I mean, early college years, from a condensed matter physicist. And because they are involved a lot in battery research and development, it's like if you want all of your effort and your educational career, your climbing of the ivory tower to be obsolete faster than any other major, go into condensed matter physics.
Sure. I do want to piggyback off this because it is directly connected. So Ford rolls out autonomous robot-operated 3D printers in vehicle production. So the title is a little misleading, I think, if you take it at face value from 3D printing industry. So they have their advanced manufacturing center has a bunch of 3D printers.
Is this your second article?
Kind of. It's piggyback off the first.
Oh, okay.
I have a different second article.
Okay. I was about to say, man, you're putting baby in the corner.
I just want to tie it to because it's directly related. So they have
I love this article, by the way.
An industrial mobile robot supporting material handling for additive machines.
Yeah.
But they're able to take this the material after it's printed to anywhere else in the facility. So it's not just within the cell. So if printing, say you have all your 3D printers on one side of the building and you're post processing the other side, which is fair because it's fair. The different cleanliness requirements for both. How do you material handle or logistically move one to another, right? In additive, there's actually a lot of material handling that's not talked about.
Yeah.
Both on the raw material side, you have build plates, you've got post-processing needs. So Ford is supporting this by using industrial mobile robot, and they're able to communicate to each other. So the additive printer is able to say, hey, I'm ready, and then the IMR will come pick it up and then move on.
So I've got a few comments because I love this article. I had a discussion about this article yesterday. First off, it's cool that this AMR or IMR at Ford's Advanced Manufacturing Facility, which is strictly their additive and automation, hands-off automation. Yeah. It's supposedly entirely automated, which is not true, and you can debunk it in the article and Ford's video in several ways. It never shows the AMR loading feedstock into the machines. Yep. So it can be assumed that is done by a human, number one. Number two, the biggest tell that is not an automation-only facility. If you watch that video, look at the lighting in that facility. Robots don't need that much overhead light.
Maybe. I mean, depending on the vision system that they could be using.
Then they're using the wrong vision system. They don't need light.
Let's give it a flashlight. Put a little strobe light on top.
I mean, I guess it needs a headlight, if that. I don't see why it doesn't have night vision.
Also, I like the fact that they're using on the Ford 500.
The GT500? The Shelby GT500? Yeah, that's sick. But the other thing, the post-processing or additive gets a lot of credit for having like zero setup time whatsoever.
Sure.
And it's like, I didn't realize until I did season 2 of Road Tripping with Steve and our first stop at the University of Texas at Austin, when Jared Allison, who's the PhD that's working, he's the technician of their advanced manufacturing facility, their additive manufacturing facility, or additive manufacturing center. I forgive me.
Let's keep moving.
He went into, there's zero setup time.
Right.
Only because all of the setup time comes after the print has been done.
Right.
Then you need to take the build plate with your parts on it carefully over to like a wire EDM and cut it off or chisel it off, which is more realistic in a lot of cases because not everybody has wire EDM. Right. You would think that if you have metal powder bed fusion or laser powder bed fusion, direct metal laser sintering, If you have that stuff, you probably have a wire EDM on site. But
Maybe.
if you're a school, probably not.
Right.
Because that's a very select technology
Right.
that you would need to be a manufacturing center facility to have that. But they're chiseling things off, and then
Sure.
you need to move the build plate to like a milling machine
Right.
to resurface it. And then the build plate has a service life.
Yep.
Because you have to remove material from it to get it perfectly even and not smooth, but like have the right surface so it's smooth, but it's also rough so you can easily weld your new parts to it.
Right.
It's
I consider the build plate similar to the pink eraser. You just keep using it till it just disappears one day.
yes, yeah.
You turn around, where did the build plate go?
Yeah, but like let's put that myth to bed.
Yeah.
Like there's not zero setup time. Just all the setup time comes after you're done with your print.
It's transferred the setup downstream.
It's like cooking. You know, just because you started in a clean kitchen doesn't mean you're going to finish with a clean kitchen.
So you got something on shot peen?
I do. I wanted to ask you what you know about shot
What do
peening.
I know? So I think we may have had it at my old facility briefly. It's a fairly caustic and tough environment, so they do it a lot in chambers. We did shot peening for cleaning parts, but we have done some of our machine components. We looked at enhancing the surface finish to increase the life of the parts. So we did a lot of chemical etching to increase the surface finish. But also they did shot peening to increase the hardness on the surface.
Okay. So I've got an article from 3D printing industry called Research Shows Shot Peening Technology Can Increase 3D Printed Part Strength by Up to 20 times.
Nice.
20x.
That's cool.
That
caught you by surprise?
It caught me by surprise. Probably number one because I don't know enough about shot peening.
Okay.
I always thought shot peening was something like, I guess, higher velocity, smaller bead blasting or something like that. Because I hear shot and I'm like, okay, we're talking about little beads.
Yeah, that's all.
Little
it is.
BBs.
They use either ceramic balls or stainless steel balls. But in this application,
Is it higher velocity?
It's yes, it's high velocity.
And are the beads smaller?
Very, very small.
Okay. So that explains why in the first paragraph they also call it, what was it? Cold micro forging?
Yep.
Wow. And that explains forging. When I hear forging, I think, okay, you're definitely making something harder.
Yeah, you're plastically deforming just the surface. So similar to like surface hardening with like a laser or heat treating it. So
yeah,
just so the outside, that first couple of grains on the structure gets compacted. So it's
that's so
increasing
cool.
the stiffness on the outside.
But it doesn't do anything to the internal structure.
Correct.
It's only surface treatment.
Correct. Anywhere you're applying. So if you have an internal hole, you could shot peen the inside of it. But in terms of the thickness of the part, it doesn't change the microstructure and the thickness.
So if they're talking about, well, two things. If they're talking about a 3D printed part with like an internal lattice structure, they can't help it.
No,
they can't do anything for it.
No, and if you look at most failure mechanics, it's going to fracture at the surface unless you get internal defects, right? If you have a pore or something like that, which is a problem additive, but most common defects, it's going to start at the surface.
Wow.
So that's why they're attacking the surface. And that's why it increases the strength of. Now that doesn't say, is it fatigue failure or is it yield or ultimate failure? But in the end, it depends on the application. That's a cool article.
It is a cool article. And my next question, and it's hinted to by the cover picture in the background behind the title.
Yep.
But I take it this only applies for metal additive, right?
Yeah, you wouldn't do that to plastic or anything else. It would just blow right through it.
All right. So has anybody ever done that? I mean, I know it seems pretty obvious, but for science, it sounds like something really fun to do.
We'll ask around.
That's awesome. All right. Well, that was my first article.
I've got one on maintenance / unexpected failures on the shop
floor.
From VentureBeat, manufacturers say unexpected equipment failure is the biggest risk to meet production targets. Some people say it's common sense, but when you go through the article and all the issues that manufacturers are going to face today, it's a fairly broad spectrum, right? So obviously just getting material into your factory, that's the LA problem, right? Just getting raw material into the factory. But they also say the second is regulatory and compliance hurdles.
Okay.
And of course, skill and workforce upscaling. Workforce in general is still an issue. But of all those, the third issue that the manufacturer's facing is unplanned downtime.
Gotcha.
Right.
Maintenance issues.
Right. And to be fair, it could be a little broader spectrum than not just the traditional sense of maintenance. Maybe not even getting a cutter in place, right? So you set up for a machine, you're missing a 5/8 end mill or a form cutter,
or you don't torque something down the spec,
and it goes flying out of your machine. Yeah. So it's a broad spectrum of issues, but in the end, it's being able to keep your machine up and running with proper maintenance and all the accessories required to maintain and keep running the machine. So I thought it was an interesting look at, of all the issues that they're seeing, unplanned downtime is still one of the top 3.
Wow. Because there's a lot that can go. There's so many variables that can go wrong in production facilities, regardless of like the actual manufacturing, the actual
right.
Bringing stock material to part form.
Right.
It's still the downtime. Wow.
And we're talking very advanced technology. So we just talk about Ford and an IMR feeding additive machines. Great. But if you're not maintaining your additive machine or your robot, that's one of the biggest issues.
So I guess that's why there's all that overhead lighting.
Exactly.
Because somebody's got to be able to fix it.
It's always got to be this one guy with a wrench making sure the machine's running.
The Ford acronym, fixer, repair, daily.
We got one on robots also in automation.
Yes. Okay. So have you heard of a company, Kinova, Kinova?
I have not.
So Kinova has been around for 15 years.
Yep.
They are a Canadian automation company. They're a Canadian manufacturing technology company.
Yep.
They have just, in their 15 years, they have just recently released their very first, and they claim the first Canadian collaborative robot.
That's cool.
And it's cool. It's relatively significant.
Yep.
But I really wanted to bring this up because I'm a hack, and I just want to say that a Canadian collaborative robot,
right.
I guarantee you this is the most polite collaborative robot in the industry. They have cornered the market.
It's going to apologize every time it does something.
It's not going to kill anybody.
Does it ship with?
Not only does it have like collision detection and does it do force stop if it notices anything, but it will apologize as well.
So this is a segment we just blast Canadian jokes.
Yeah. You know how like collaborative robots, they even slow down as they detect something approaching.
Yep.
Bet it even apologizes then.
For slowing down.
Not even it prevents the collision. Yeah. Still apologizes. Sorry. Sorry for bringing this article up.
Steve, we talked about Formula One. Was that last episode?
Formula 1.
And
yeah, we did talk about it last episode.
I got an article from Metrology News about Formula One. Interesting intersection.
Heck yeah.
The intersection of all the great things. Formula One, F1 race scrutineering to check car geometry using laser tracker and 3D laser scanning. There's a couple of questions here, Steve. I need you to educate me on.
Okay.
What is scrutineering?
Scrutineering is not just Formula One.
Yep.
It's also in Le Mans, but it's also not just in the highest level of motorsports.
Okay.
Scrutineering shouldn't be associated with racing, and it shouldn't be associated with like high level motorsports. It should be associated with any time you put a vehicle out on a track. Every time race tracks are very expensive.
Yep.
They are very expensive to maintain because they're infinitely better than public roads.
Sure.
And they get a lot less service than public roads.
Right.
And they don't have the beauty of the taxpayer to pay for them. So a lot of money goes into them.
Yep.
And even if somebody shows up to the racetrack and wants to pay a lot of money to take their car or vehicle out onto the track, before they can, the track owners, and it behooves anybody who has to maintain or anybody who is in charge of that track to the slightest degree to be all about scrutineering.
Right.
And scrutineering is making sure the vehicle that is about to go out on this racetrack or a racetrack isn't going to harm the racetrack. Okay. The racetrack comes first. Then you want to make sure the vehicle doesn't harm other people on the track. And then you want to make sure the vehicle doesn't harm the person who's trying to operate the vehicle.
That's fair.
You want to make it's basically a safety check. It's
right.
like your safety inspection, but way more intensified.
Yep.
Or less so, because you can take a vehicle that has not passed your state safety inspection to a racetrack and it might pass there.
Right.
They do things like they make sure your headlights, if they're glass, even plastic in some cases, they make sure your headlights are taped off because they don't want shattered glass on the track.
Yep.
They check your machine for mechanical soundness. Like, is it leaking oil or coolant? Because they don't want that on the track. That will harm other people. It will harm the perfect surface of the track.
Yep.
You know, they don't do stuff like checking alignment, but in racing, it's much more than that. In the lowest level, on like a public civilian level, they're making sure the vehicle is sound and not going to hurt anybody, or more importantly, the track itself.
Yep.
It's to keep the track safe.
Yep.
On the second, in high level racing, it is to make sure that the cars are following the rules.
Yep.
So in auto racing, like Formula One and Le Mans, or the 24 hours of Le Mans, it is a driver. Like, those are two totally different schools of race. So let's just stick on Formula One. The faster racer, race car driver, and race car isn't necessarily the fastest car. In Formula One, it sometimes sadly is.
Sure.
But in terms of driver talent, the only thing that determines one driver from another, like which one's better, is who makes less mistakes.
Sure.
They all do the same correct things,
Right.
but the faster driver makes less mistakes. A car or one driver is passed by another because that person made one more mistake than the person behind them.
Yep.
And scrutineering makes sure that the playing field is as level as possible.
Right.
Like scrutineering in the 24 hours of Le Mans is there's actually a plank of wood underneath the cars that as the cars go over this hump on the Mulsanne Straight, which is the back straight of the track, it wears away the bottom of the car if the car is too low. So there's no regulation for how low the car is, but there is a regulation for how much material you have on the bottom of the car.
Right.
So if they measure that wood at the beginning of the race and it is like to some metric,
Sure.
like it is by the end of the race, by the end of 24 hours, it is allowed to deteriorate by, let's say, a quarter of an inch.
Right. Right.
I don't know what it is, and
Sure.
I'm sure it's in millimeters, not inches. If it goes beyond that, that car's disqualified.
Wow.
Because let's say they're using a thinner piece of wood to save weight, which sounds crazy, but they do everything they possibly can.
Yeah.
Formula One's the same.
So in this case, what they're using are handheld laser scanners to check the geometry of the outside of the car. So previously, you could use measuring tape or different mechanics.
That's awesome.
Mechanical ways of checking the car. But in this case, what they want to do is get to a faster decision. Also, so being able to collect the data to make a decision.
That's cool.
And also they talk about the complexity of the parts. So if you see in the Formula One, which we talked about how interesting they look recently, it's a very, very complex surface. So making sure that there's compliance both on height and there's regulations on the overall shape and what they're allowed to do and aerodynamically. Verify that both before and after the race, right? They're changing parts throughout the race also.
Oh, yeah.
So it's interesting that they go through this part, and also they're doing this at the race day, at the race weekend.
That's so cool.
Friday's practice day.
Yeah.
Saturday's qualification. Sunday's race day.
Yeah, there's no scrutineering that takes place like for qualification or practice.
20 cars that you're going to check over the weekend, and you have to make a decision very, very quickly.
I mean, there's the track safety check, but the scrutineering is almost like an event on its own. Points can't be made in scrutineering, but their disqualifications can happen during scrutineering.
So I really like the ability. One, is massive, right?
Yeah.
In terms of the size of the car and the environment that they're checking, and also, I mean, to be fair, laser scanners aren't, in general, have been in the industry for a little bit, but the application into open environment, right? They're in an open garage. They're checking these.
No, they're out in the open. They're on the track,
and then they're doing this quickly enough for 20 cars at a race weekend to get all the information and a decision made very quickly throughout to make sure the race occurs, right? I mean, you'll continue the race, and they could theoretically disqualify you afterwards, but they want to be able to make a decision very, very quickly. So I thought this very interesting life cycle of checking a part, collecting that and getting to analysis in a non-manufacturing environment, right? These guys are just
It's really cool. But it ties back to manufacturing because we have noticed a trend in handheld laser scanning technology has been blowing up lately, and it speaks volumes that Formula One is adopting it.
Yep.
That's the pro. That's the cool thing. The con, the only concern that I have, and it's probably minimal, is that it could cause scrutineers in the training of FIA controlled certified scrutineers to get lazier because the technology is better.
Maybe.
But that's with any technology.
Sure.
That's a risk with any improving technology. But I will say, I bet you what drove the development of this handheld 3D scanning technology is the FIA regulations prohibiting the use of originally tire ovens and now tire warmers.
Yeah.
So tire warmers aren't allowed anymore.
Oh, really?
Yeah.
This year they're not allowed.
They're allowed before the race, but they have to be turned off at a certain time before the race starts.
Wow.
And naturally, I'm sure a few of the teams have been like, well, the scrutineers better hurry up then because we're losing precious degrees.
Yep.
But yeah, like to just elaborate on the background behind that, tires, especially high performance tires, work their best. They're produced and developed to provide maximum grip at to maintain grip up to like 4 Gs of lateral force. And to do that, you need to be at an extremely high temperature to keep that rubber at a glue-like consistency so it can literally stick to the road. And you want to keep it hot. And if you're not cornering hard enough, like if you're like just driving Miss Daisy around the track, you're not driving hard enough to keep the tires at temperature. And when they go below temperature, they become like rocks they just slide everywhere.
Which is why you see them weaving back and forth after
they're
safety
scuffing
car.
tires.
Right, they're trying to maintain temperature.
And it's crazy. Those tires degrade so quickly. By the end of a 60-lap Formula One race, you can see the perfect road where all of the cars have gone. That's the driver's line around the track, and on the outside, it's just like riddled with like black debris, which is called clag. That's the technical term. Clag is chips, if you would, of the tire material, the rubber.
It's a minefield outside the
yeah,
line.
you do not. And what's actually really fun? I'm sorry, last thing. On like the final lap after the race, the cars that have actually completed the race, you'll actually notice as their tires are still hot, they will drive over the clag to keep their hot, sticky tires to pick up some of the clag to add weight to the car after the race, because there's a post-race scrutineering too to make sure that the car is not underweight. And they do that just as a safety precaution to make sure, just in case it is slightly underweight, just picking up those extra few ounces of rubber on the sticky tires can keep you within spec and from being disqualified.
Scrutineering, man.
Scrutineering, baby. Inspection. Everybody hates inspection.
Today's episode was sponsored by AM Radio. Where can they find more info about us, Steve?
amtonline.org/resources. Like, share, subscribe.
Thanks, Steve.
Bye.
Bye, everyone.